All right, so let's go through the steps of a hypothesis test. We're going to use the mnemonic phantoms for this. So very similar to panic. Panic is the one we use for confidence intervals. Phantoms is the one we'll use for hypothesis test. So the P in phantoms is the statement of what we're doing. So it's a parameter statement. So we're testing the claim, maybe that the amount of vitamin C is less than the advertised 500 milligrams. Okay. The H is our hypotheses. So the null hypothesis, H is 0, and put mu equals that number. And then HA is our alternative hypothesis. So that's either mu is less than, greater than, or not equal to, different than. And then just remember those two numbers are the same. The A in phantoms is the same as the A in panic. So we're looking for a simple random sample so that we can apply our results to our larger population. We're looking for either a normal population or a large enough sample, meaning n is equal to 30. Okay, so that gives us our central limit theorem, and this is our inference. And then we're looking at our population standard deviation, sigma, is known. Okay, so this tells us that we have a Z as in zebra distribution. The name of this is a one mean Z as in zebra test. Okay. To calculate our test statistic, we're going to do x bar minus mu, and then we're going to divide that by sigma over the square root of n. So there's that piece that we were using in our confidence interval as well. Okay, and that you also used in chapter 15, so that guy should look familiar. And I have a spreadsheet for you that'll help you calculate this as well as obtain your p-values. And these are the formulas for those. And if we were still here on campus, I would be helping you set that spreadsheet up. But since we're not, I'll just provide that spreadsheet for you. It's actually just a different tab on the spreadsheet you already have. Okay, so you'll get the p-value from there, and then you're going to make a decision. So O is obtain the p-value, M is make a decision. So you're going to compare that p-value to alpha, and then your decision is either reject if p is less than alpha, or do not reject if it's not less than alpha. And then S is state the conclusion. So you're going to say with a p-value of, and you'll put your p-value here, at the blank percent significance level, we either do or do not have. So that you're going to get that from here. You either do reject H naught or you do not reject. So we do or do not have sufficient evidence to conclude, and then you'll get that context again from your original parameter statement at the beginning. All right, so let's give this a try. I think it'll be a whole lot easier to see this in action. So if you go to page 2, we have this one with the credit card company again. That we looked at the hypotheses earlier. So the board of a major credit card company requires the mean wait time for customers for service calls is 3 minutes. To make sure that the mean wait time is not exceeding the requirement, an assignment manager tracks the wait times of 45 randomly selected calls. The mean wait time was calculated to be 3.4 minutes. Assuming the population standard deviation is 1.45 minutes, is there sufficient evidence to say that the mean wait time is longer than 3 minutes with a 98% level of confidence? Okay, so you will occasionally see it worded this way. This is getting at what your alpha is supposed to be. So your alpha is at 2%. Okay, so it's just the leftover on this. So remember, your alpha is always between 0 and 10%. Okay. If you have questions about that, you can always ask me. I try to double check the problems to make sure that they are a little more explicit about what that alpha is. Okay, and if it's not stated, just use the 5%. So our letters for this are going to be phantoms. So I'm going to go ahead and put those on here. Okay, get that all spelled out. So P is the first one, and this is kind of what we're doing. So the claim that we're testing here is the mean wait time is longer than 3 minutes. So mean wait time longer than 3 minutes. Okay, something to that effect. It doesn't have to be a complete sentence. That's totally fine. Hypotheses. So I need a null and an alternative. We know that they both start out with a mu. Okay, so the company claims that these calls are taking 3 minutes. So we know the number for both hypotheses have to be the same, so we'll use 3 for both of those. And then we're looking for evidence that the mean wait time is longer than 3 minutes. So mu is greater than, which means this is a right tail test, in case you're interested. Okay. And then the A is our assumptions and conditions. So this is the same as the ones we were looking at in chapter 16. So hopefully you've got these down pretty good. So simple random sample, normal or large, and then sigma. So do we have random? Oh, yep, we have randomly selected. So check that off. Let's see, our sample size is 45. So I'll put down n equals 45 and circle the large because that's certainly bigger than 30. And then our population standard deviation, so sigma, is 1.45. So perfect. So we have all of those. And then while I'm here, I have this other number. The mean wait time for those 45 calls, that's my X bar, is 3.4. So might as well write that down while I'm here. Perfect. Okay. So N, this is a one mean z-test. And then it's time to calculate my test statistics. So since this is a z as in zebra test, the value of my test statistic is z equals. Okay, so that number matches the distribution. And so this is x bar minus mu sigma over the square root of n. So we'll fill these numbers in. So my x bar I already found, minus mu. I get my mu actually from my null hypothesis here. So my null hypothesis is mu is equal to 3. So this is 3.4 minus 3. And then there's my sigma and my n. So I can fill those in. And then I'm going to go and switch to Excel so we can calculate that and get our p-values. Let me do that quick. Okay, so here is our Excel spreadsheet, and down at the bottom we have these tabs. So here's the one you were on before, the chapter 16, and you can switch over to the chapter 17 one. So we'll put our X bar in, which was 3.4. We'll put our mean in, which is 3. Sigma was 1.45, and n was 45. Oops, I wrote n there instead of writing 45 on the paper. Let me fix that quick. Okay. And when I did that, now I have my test statistic. So it's z is 1.85. So I'm going to write that down on my paper. And I would like you to do that on your homework and on the classwork, is write that down. And then I need to pick my p-value. Okay, so I have 3 p-values listed here. I have a left tail, a right tail, and a two tail. So remember when we were looking at our hypotheses and we were writing them down earlier, and I said, oh, I have a right tail because I have a greater than? The reason I noted that was because that means this is the p-value that I want to write down here. So it looks like my p-value is 0.032. So I'm just going to write that down. Okay, and that's all I need from the spreadsheet, and I'm ready to finish up writing this. Okay, we'll go back to our classwork to finish that. Okay, so you'll notice I wrote down the test statistic here to fix that little goof. And then I wrote down my p-value. So there's my p-value. And my alpha is that 2%, so 0.02. And then which one of these is bigger, 0.03 or 0.02? Well, the 0.03 is bigger. So that looks like this. And if I look here for make a decision, if p is bigger than alpha, I do not reject. So for the M for make a decision, I write do not reject. H naught. Okay, and so my conclusion statement here, right? So it certainly helps to have this kind of little write-up to work with the first couple times. So with p equal to 0.03 at the 2% significance level. Okay, so I just got those from right here. So the next part of this is we either do or do not have sufficient evidence. So we do not have sufficient evidence. Sufficient evidence. And then we just need to add the context. Okay. So and our context is going to come from up here. So the mean wait time is longer than 3 minutes. So with p equal to 0.03 or p 3 equal to 3%, that's fine as well. At the 2% significance level, we do not have sufficient evidence the mean wait time is longer than 3 minutes. Okay, so there you go. There is your first hypothesis test.